Ever found yourself pondering over how radar and acoustic sensors function? Well, today we're going to dive deep into the operational principles of active sensors. Now, whether we're talking about electromagnetic sensors like radar and laser, or active acoustic sensors such as ultrasound and sonar, the principles remain the same. First off, we need a source of radiation. This is fed to a transmit antenna. Picture this as the starting point of a journey. The radiation is like a traveler, ready to embark on a mission. Next, the radiation needs to be tuned to the characteristics of the target. Think of it as fine-tuning a radio to get the best possible reception. Only in this case, instead of catching the latest hit song, you're trying to detect an object or measure a distance. Now, it's not just about tuning. The radiation also needs to be matched to the impedance of the medium to maximize coupling. Imagine trying to fit a square peg into a round hole. It's not going to work, right? The same principle applies here. The radiation needs to be the right shape to fit into the medium. Once everything is set, the radiation is radiated by a directional antenna to increase the energy on target. It's like focusing a beam of sunlight with a magnifying glass. The more focused the beam, the more powerful it becomes. The journey doesn't end there. The radiation then impacts on the target of interest. This impact results in a change in impedance, which then triggers re-radiation or scattering. This re-radiation can be isotropic, random, or directional. It's a bit like throwing a stone into a pond. The ripples can spread out evenly in all directions, isotropic, scatter unpredictably, random, or move in a specific direction, directional. Some of this reflected power then enters the receiver antenna. This is where the journey comes full circle. The radiation, having completed its mission, returns home. But it's not over yet. The received signal is converted to an electrical one. This is like translating a foreign language into one we understand. Finally, the electrical signal is amplified and detected. It's like turning up the volume on a speaker to hear the music better. And there you have it, the operational principles of active sensors. From the initial radiation source to the final amplified and detected signal, it's a fascinating journey of transmission, reflection, and detection. Remember, whether it's a radar scanning the skies for aircraft or an ultrasound device peering into the human body, the principles remain the same. It's all about transmitting radiation, tuning it to the target, matching it to the medium, radiating it with a directional antenna, causing an impact on the target, triggering re-radiation, capturing the reflected power, converting it to an electrical signal, and finally amplifying and detecting it. Understanding these principles not only helps us appreciate the technology around us, but also opens up a world of possibilities for innovation and problem solving. So the next time you come across a radar or an acoustic sensor, remember the incredible journey of the radiation that makes it all possible.